Next paper is Plunger Lift Optimization, a case study of monitoring plunger dynamics with non-intrusive acoustic tracking, Mr. Muhammad Hassan Chaudhary. Mr. Hassan Chaudhary is Deputy Manager Production Engineering at United Energy Pakistan Subsurface Division. He has more than 5 years of versatile experience in E&P industry, including the services sector. His proficiency spans domains such as production optimization, well performance, well integrity, well stimulation, rigless operations, planning and implementation, and evaluation of new technologies. His academic background includes a gold medal from NED University of Engineering and Technology in Petroleum Engineering. Please start.
So this is Hassan Chaudhary. There has been a recent change. So I'm currently working as Deputy Manager in Commercial Department at United Energy Pakistan or UEP. At the time of writing this paper, I was part of the Production Engineering and Technology team, where I was directly involved in the acquisition, trials and implementation of this technology. So my paper is on plunger lift optimization, and this is focused on some case studies that utilize the non-intrusive acoustic service to track and monitor plunger dynamics. So I'll be starting with the agenda of this presentation. I'll be starting with a brief discussion on the basics of plunger lift optimization. Plunger lift operation, followed by a brief overview of the acoustic survey equipment, the working principles of plunger tracking, its value addition, and how depth correlation and interpretation is carried out, and lastly the case studies, results, and some operational recommendations from our end. So just a brief overview of how plunger lifts actually work. So these systems utilize the reservoir's own energy to lift liquids from loaded up wells to surface, and thus that makes them a very cost-effective solution because there is no external energy in the loop. So a piston-like plunger reciprocates up and down the wellbore that lifts the liquid up to the surface. That reduces the flowing bottom hole pressure, increases the lift, and it allows sustainable flow from the well. The plunger cycle consists of majorly two phases: a shut-in phase where the well is shut in at surface, and the bottom hole pressure and well pressure is allowed to build up. During this, the plunger falls to the bottom and rests on the bumper spring assembly. This is followed by a flowing phase where a pressure differential is basically created across the plunger that provides it the energy to lift the weight of the plunger itself and the liquid that has been accumulated over it, it lifts to the surface. This is primarily known as the unloading period, and is part of the two processes that are occurring in the flowing phase. The other being if you can see on the animated part on the bottom right of the screen. So the other being the afterflow period. So the afterflow period is basically when your plunger has reached back up to the surface and is caught at the lubricator, and the well continues to flow gas into the system at or above critical velocities. So these cycles are automated via motor valves that are controlled by electronic panels, and these electronic panels have preset timing configurations that define the start and end of each period, the shut-in period, the unloading period, the afterflow period, to simply put it. So these cycles repeat throughout the day to ensure the liquid removal is consistent to maximize production from the well. We have fundamentally two types of, we can categorize the types of plunger in broad two categories. a slow-moving solid type plunger, and there are some fast-moving continuous or bypass type plungers. So the bypass type plungers have a few ports that run through the entire length of the plunger, and these ports allow the gas to escape through them when the plunger is falling. This allows the plunger to fall much faster than the solid type plungers. Right. So, having established that context, now the plunger lifts require frequent adjustments, particularly in the time parameters. You know, due to the varying reservoir conditions that arise due to changing well dynamics, because the liquid loaded well is now unloading liquid. You know, these changes may include varying GLRs, the gas lift ratios, declining bottom hole pressures, or some performance issues as well. For example, incomplete plunger travel or overcycling or liquid fallback. So now, you know, the traditional methods, they utilize mostly gas work to estimations to counter all these issues. But the truth is that all these issues are difficult to detect through without the presence of a dynamic monitoring tool and just with gas work. So this is where plunger tracking comes into the picture, which is obviously non-intrusive, which is the main benefit of it. And just for context, you know, these wells are very marginal, and costly well intervention is not always an option. So, and even when it is an option, you don't have very much options for well intervention, because, you know, if you imagine there is a foreign object, which is the plunger cycling up and down the well, and we don't want it to stop, it cycles throughout the day.